Okay, so we're going to take notes on the scientific method. So the first thing I'm going to do, I'm going to go up to insert. I'm going to insert myself a table. And we can probably just do something like this. And if you remember, I can then drag this over to about here, go up to the home key. And here I'm going to type in key terms. And over here, details. Oops, too far. And then I'll go down to here and I'll get myself a bullet point. And just like if you were in class, I'll be showing the PowerPoint over here. What you're typing should go over here. So we'll go ahead and go scientific method. You guys are all probably familiar with it. And really what it is, it's a series of steps that are used to investigate something. So our first key term is actually going to be scientific method. And our first bullet point, series of steps to investigate. And depending on where you went to elementary school or what you've seen before, you may have heard that there are exactly this many steps, the scientific method, and they have to be done in the same order every time. Nah, not really. In fact, there really is no one method for investigation, and sometimes steps are going to have to be skipped or done in a different order, depending on what you're doing. So I'm going to go up over to here. I'm going to hit enter. Give me another bullet point. No one way to investigate. And sometimes steps might be skipped or switched. So I'll go over here. And now I'll actually talk about the scientific method. And here are the steps we're going to talk about. Problem, question, observation and research. Formulate a hypothesis. Investigate. Collecting data and analyzing results. And your conclusion. All right, those are the 6 steps of the scientific method. Unless, of course, they're not. And then last but not least, communicating results. So 7 steps. So let's talk about number 1, problem question. So I hit my tab key, go over to here, and type in problem / question. Give myself another bullet point. And every investigation starts with a question or a problem that can be solved through experimentation. Okay. So my first step is going to be to develop question or problem. Okay. And here's the big thing, the question or the problem must be testable. So it's not like any single problem can be testable, right? If I want to know how long it will take me to skip from Zionsville to Indianapolis, that's a testable question or problem. If I want to know how many elephants are going to fit in the gymnasium, probably not a testable question. Technically, maybe it could be done, but realistically, probably not. So it must be a testable question. But everything starts off with a problem question. The scientist says they're just going to investigate just for the heck of it. They're trying to find the answer to something. Next step is going to be observation and research. So I'm going to go here, I'm going to hit my tab key. Observation / research. And we got to make observations and research the topic of choice. Okay. When we do this, our research has to be from reliable sources. And not only must they be reliable, but they must be verified by other scientists. Okay. And last but not least, opinions are not valid research, even by other scientists. Right? Albert Einstein, his opinion, if he thinks that unicorns are real, because that's Albert Einstein, does that make it real? Absolutely not. So we're going to come over here, and we have to make observations and start research. Our sources must be reliable. They must be verified by other scientists. And opinions are not good sources of research, even from scientists. All right. I'm just going to move this over here just a little bit. Hit my tab key, get another one. And we'll go on to step 3, which we've spent a bunch of time. Hypothesis. So again, hypothesis is where you're going to predict possible answer to your problem or your question. And then, of course, we're going to use the if, then, because format. Oops. Predict answer. And, of course, use if, then, because format. Put this here. Okay. All right, next one is going to be designing an investigation. Now that you've identified the problem, you've done your research, you've made your hypothesis, now you need to figure out how you're actually going to go about trying to find the answer. So we have to design an investigation. And there's 4 basic ways that we're going to talk about investigating. We're going to have an experiment. Right? That's the first one. So I'm actually going to go here and instead of a bullet point, I'm going to go up here, select the number. Did not want to do that, so we're going to go here and get rid of this. Let's see if this will work. There we go. So an experiment. That's probably the most common or most popular one. So when you have your experiment, I'm going to go here and I'm going to go indent here. It's going to give me this. I have to identify the variables. I have to devise my procedures, which are step-by-step instructions for completing a task, and I have to include a materials list. So I have to identify. We'll just put independent variable, dependent variable. Actually, we'll change this. Because of course, we have to identify our controls. And we have to devise our procedures. Oops. Step-by-step directions. And then we have to include a materials list. Next thing over here, sometimes you don't need to do an experiment. Sometimes you can do a survey. So if I hit enter, it gives me a D. I don't want that. So I'm going to go back over to here. And it goes right to number 2. I'm going to type in survey. And a survey is just simply questions that are answered by people. I'm going to hit enter. I'm going to go in here again. You've probably done these many, many times. It's because surveys are great for opinion questions. If I want to know the favorite color of 5th graders, I'm not going to design an experiment. I'm going to ask them. I'm going to survey them. So depending on the question or the problem you're trying to find out, sometimes the survey is your best bet. All right. And they can be interviewed in person, phone, email. It really just depends on what you're going to do. Okay. Next one is going to be sampling. Again, that. Back. Type in sampling. And sampling is examining random individuals in a population. So I'm going to go here. I'm going to go in. And what they do when they samples, they don't sample everybody. If I want to ask the whole state of Indiana favorite TV show, I can't get a hold of all 4 or 5 million people or however many people are in the state of Indiana. So what you're going to do is you're going to examine a certain number, and it's all done by a mathematical formula. And then we're going to apply those results to the whole population. So if I were going to ask, if I wanted to survey Zionsville West students on their favorite color, I'm not going to ask all 1,200 kids or 1,000 kids. I'm going to pick maybe 50 in each grade. Okay. Now you would have to keep certain things. You have to make sure that you try your best to do the same number of boys, girls, and stuff like that. And you wouldn't want to do 100 5th graders and 25 8th graders. You'd want to keep everything like that the same. But depending, you have to get enough, and then you can just apply the results to the whole population. And then the last one are models. Oops. And models are objects or ideas that represent other things. And models are really, really useful, especially if you're trying to question something that's really, really large or really, really small. Because models can be larger or smaller than the real thing. Scientists want to find out how what an atom looks like and try to answer questions. They're going to use a model. Or if we want to try to figure out, astronomers want to try to figure out how planets orbit in a galaxy. It's really hard to go out and look at that. Too far away. The universe is too big. They make a model. Or sometimes, if you're making a new plane or a new car, you have to test certain things. And the easiest way to do that is you make models. You start with a smaller model, and you build up and up and up. Okay. All right. Next thing, we're on 5, guys. There's only 7 steps in our thing. So I'm going to go down here, and I need a new column or a new row. So I'm going to hit Tab. It's going to give me a new one. Right, and I'm going to write collect data and analyze results. I'm going to get rid of that and put that back, and it should be fine. And once you've collected your data, it's the information. So we have to use that. So data, our information. Lets us, we'll say form conclusion. And it can be quantitative or qualitative. Remember, quantitative is measurable stuff. Qualitative is observational stuff. I'm going to go in here. So sometimes we'll get measurements. How many times a cricket chirps in 5 minutes? Sometimes we'll get a qualitative appearance of cleanliness. That's still our data. And the data must be organized. You can't just throw it out there. Right? And usually that means using a table or a graph. Must be organized. Use a table or graph. And so when you do your, I talked about how next week when you go in the lab, you're actually going to develop your own investigation. You're going to get data. You're going to collect data from your investigation. You're going to organize it in a table or a graph. All right, and then you come to your conclusion. And your conclusion is when you accept or reject your hypothesis. And it's okay either way. Some of you will be able to accept your hypothesis. Some of you will not. Some of you will find out what you thought your prediction was going to didn't work out. And you're going to want to suggest possible improvements to the investigation now that you've done it. You know kind of maybe what you could do better. If you get the results you want and they're good and your hypothesis is accepted, you have to retest it. One time is just not good enough. All investigations must be repeated more than once. And the results must be the same every time. Right. So we're going to go back down here. Confirm results by retesting. And investigations must be repeated more than once. And results must be the same every time. And if you get it, same results many, many times, you get what's called a theory. Many times. And the last thing, one more, is to communicate results. And this is where scientists share their investigation and the results with others. Right? And they can do this many ways. They can publish articles, websites, things like that. And they do this because they can learn from each other by answering questions. Most likely, if you're looking for the answer to questions, so is somebody else. Right? And now you can actually become part of somebody else's research. So, learn from each other by answering questions. Okay. All right, we made it. So remember, the 7 steps of the scientific method, even though that's not necessarily always the case. Problem and question, observation and research, formulating a hypothesis, conducting your experiment, collecting and analyzing your results, writing your conclusion, and then communicating the results. All right, I think we got it. Make sure you've saved your notes somewhere that you can find them tomorrow for class, because we'll be looking for them. Thanks.